Welcome to another beginner's guide to Advent of Code 2022. In this video, we are looking at day 5 supply stacks. We're going to go over our approach on how to solve this puzzle. It should be accessible to anyone who has learned the basics of coding. More specifically, you need to be able to parse strings, do substrings, index into strings, perform Boolean logic, do loops, and know about resizable arrays or lists. I've also posted a link to the puzzle in the description box below this video. And of course, if you get stuck, don't hesitate to post your questions in the comments or make a post on the Advent of Code subreddit. Lots of people there absolutely willing to help you out. And of course, if you find this guide helpful, let me know, click the like button. And if you want to see more, go ahead and subscribe so you'll know when the next guide is out. All right, let's go. With the beach clean, the elves are ready to unload the remaining supplies from the ships. The supplies are stored in stacks of marked crates. This makes it difficult to access the contents of crates stored at the bottom. To access crates, the elves use a giant cargo crane to move crates between the stacks. After the crates have been rearranged, the desired crate will be at the top of each stack. To quickly unload the necessary supplies, the elves want to know which crate will be at the top of each stack after a series of instructions are followed. Can you determine which crate will be at the top of each stack? Happy Monday, Captain Coder here with day 5. That's 5 of the Advent of Code 2022. I'm itching to get off this beach and into the jungle with our elf friends here. We got to find some magical star fruit. We have to feed it to the reindeer. We have to save Christmas. To do this, we have to figure out which container is in the top position of our stacks. In my opinion, the most challenging part of this problem is actually figuring out how we are going to parse this input into our program. That's most of the puzzle. Once we have it into a data state that we can use, once we're representing it well, the problem becomes pretty straightforward of just moving things between these stacks. So we need to come up with a strategy here on how we're going to do this. The first thing we're going to do is we're going to figure out how to represent our supply stacks, what data structure we're going to use for that. Then, we're going to pull in our input and actually build up that data representation. After we do that, we need to do the same thing for the instruction part of our input. So then we're going to come up with a representation of how we're going to store our instructions and then parse it in to that data structure. Once we have our inputs parsed into data we can use, we need to write a function that's going to allow us to take an instruction and apply it to our supply stack data. And with that in place, we can just iterate through all of the instructions we've parsed in and get our solution. With that strategy in place, let's dive in. All right, so the first thing we need to do is select a data structure to represent our supply stacks. And we need to consider what do we need to be able to do with the supply stacks. In this case, we need to be able to take something from the top and put something on the top of each supply stack. This is often called pushing, which puts something onto the stack, and popping, which takes something off the top of a stack. Many languages actually provide a data structure called a stack that you can just use out of the box. The main thing to consider here, though, with this data structure is it resizable? Can this data structure change, grow, and shrink as we need it? In many languages, this rules out a simple array. The second thing we need to also consider is that we need to have a collection of all of our supply stacks. So we need to think about how we're going to represent all of the supply stacks together, and our instructions actually index the supply stack. So we need to be able to say, I want supply stack 1 or supply stack 3, whatever it might be. Think it over. If necessary, do a little bit of research on your language and then choose a representation that you think will work. All right, so hopefully you've found a data structure that'll work for you. Now that you have it, just verify that it meets all of the properties here. That's what I've done. My plan is I'm gonna use a list of characters. So the outside list represents all of my supply stacks and the inside list represents an individual supply stack. So that's how I'm going to encode my data. So here in my code, I've written little tests to make sure I can perform all of the necessary operations. I start by creating my whole supply stack array for testing. I add a simple supply stack to that list, and then I check, can I index in there? I sure can index that value using 0 here. I can push to the top of my stack using insert at 0 followed by the element. So I'm gonna put an A here just to make sure I can test that. So I can insert to the top of my stack. I can access the top of my stack by indexing 0. And then I can also pop, I can remove the top element by using remove at 0. So before we continue, make sure that your data structure can do all of these things. All right, so hopefully you are ready to go. You have your data structure. The next thing we're gonna do is we need to actually figure out how many of these stacks we need. So I'm gonna recommend writing a function that will take in the first row of your input, and from that single row of input, determine how many stacks you need and initialize. So for me, if I pass this in, it would initialize a list of 3 empty stacks. Then go ahead and get your input, your big input file. Scroll down, get your big input file, copy that first line from that one as well, and see if it also produces the number of stacks you need for that input. In this case, I have 9. So, all right, so I've written myself a little test here with my function definitions, but haven't implemented my functions. So I've gone through and created 2 strings, one for the example input and one for my full input. And then I have this init supply stacks function. This is a method that I've written that's gonna take in that string, and the plan is it will initialize to the correct size and then display when I run this right now. If I run it, it's going to say that these are size 0 because I just return an empty stack. But the idea is I'm going to calculate how many stacks I need and populate this stacks list with that many supply stacks. So give it a shot now, see if you can get that to work. Hopefully at this point you have a working init supply stacks method. Mine, I've just run my test here, I've implemented it, and I have some confidence that it's working. So for this one here, this input here, for the example, I get back that it has a length of 3. And for my personal input, I get back that it has 9 columns, which is correct. So with this test, I have some confidence that it's going to work for both my example and my personal input. If you haven't got yours working yet, go ahead and pause. I'm about to show my solution. All right, so right here I have my init supplies. It takes in this string row, and I need to calculate how many of these I need. I've done this. I know that my row is gonna have a specific number of characters, and I know that it is based on 4. So I have a container every 4 characters moving across, but the last one there's no space, so I have to do this +1 here, so I get the row length, so the length of my input. I add 1, and then I just divide by 4, and that tells me how many things are going to be inside of my container here. And then I just do a quick loop that says for this many number of times, go ahead and create a supply stack, and then finally I just return it. Fantastic. So next we need to actually parse in our rows. To do this, I recommend writing a function that takes in an individual row, just a single row, as well as all of your stacks, and parses it appropriately, pulling out the appropriate characters and adding them to the appropriate location. I've written a little test, and I recommend you do the same. where I actually initialize based on my sample row, my example row, and then I'm going to go ahead and parse that row into my stacks and do it for each of the inputs. So there's 3 inputs here. And so the idea is that after I've implemented my parse container row, I can run my program and it's going to give me confidence. So at the end of the day, I should, after I parse just D in, my second stack should have D in it. After I parse NC, it builds it up so I have N in the first, D and C in the next. And then finally, when I pass this last one in, I should have NZ, DCM, and P. So go ahead, give this a shot, see if you can get your parse container row working for an individual row, and then run your test to give yourself confidence that it's working. All right, hopefully you now have a working parse method for an individual row and your tests are validating, giving you confidence that it's going to work on your larger input. So let's take a look at what my output is. I have a D coming in here and that's going to go into stack 2. Then I have an NC, so this is going to be stack 1, stack 2. Notice here my stacks sort of, they're not in reverse order, it's just printing this way. I have an N in stack 1, then I have DC, so D is actually the top of stack 2 here. Then the third input ZMP, I get NZ, DCM, and then P is added in here. So this gives me confidence here that the input, my parse, is working. So if you haven't quite gotten that working yet, go ahead and pause. I'm about to show my solution. So down here, I'm taking in a row, I'm taking in my stacks, I'm looping through, I'm just iterating through all of my stacks using an index I. So I know that each chunk of characters has 4 in it. So I'm multiplying that index by 4. All right, so when I get the 0 index in, that's not gonna move it over at all. And then I add 1 to it here. So for example, I times 0 plus 1 gives me position for that first character in my stack. If I multiply it by 4, it's going to go to position 5, which happens to be this cell here. If I multiply it by 3 and add 1, that happens to be this cell here. So I can extract just that individual character from my string. Then I check if it is a blank, I do nothing. So if it's not a blank, I need to add it, and I just add it to my appropriate stack here. One thing that you might run into, so one thing to keep in mind before we move on, you want to make sure that as you're parsing these things in, you're not simply calling push because it's coming in top down. If you call push, you're going to end up with everything in reverse order. So for my solution, since I'm using a list, I can actually add them in order as they're coming in. So D comes in first, then C, then M. If you are using a stack-like data structure where you're pushing things, they're going to be in reverse order. So you may have to add in here, if you're using a stack structure using push, you may have to add in a reverse. Just verify before you move on that your stacks, in fact, are in the correct order, that the top elements of each one happens to be N, D, and P. With a working parse container row method, we are now ready to parse in all of the rows and get our stacks. So I am going to recommend you write a new method, a method called parse supply stacks, which actually takes in an array of rows, so all of your input, and actually initializes all of your stacks to their initial state based on your input. I've written a little test here to help me do it. When I run it, it's going to actually print out my stack 1, 2, and 3, and then I can verify it against my example. So the way it works is I read in my files into rows, then I pass those rows into parse supply stack, which is going to call my init supply stack with that first row. So this is actually going to give me back an initialized stack. Then I need to actually write the code that's going to go through and pull out each one of these rows, parse it, and modify my stacks. To help with this, I'm also going to recommend writing a little helper function called isContainerRow that, given a row, will tell you whether or not that row happens to be parsable by our program. So go ahead and give it a shot. write your test, and verify it. Ideally, you now have a parse supply stacks method, which takes in your full input and returns to you all of your supply stacks with the appropriate containers placed inside of them. You should be able to run your test and verify that that's the case. So here I am, stack 1 has N and Z, stack 2 has DCM, and stack 3 has P, which matches our example here. If yours isn't quite working, go ahead and pause, fix it up, and then come back, see my solution. So here we are, not too bad. I'm gonna take all of my rows, and all I'm gonna do is I'm gonna iterate through all using a for each. If it happens to be a container row, I just call my parse container row method, which will modify my stacks for me. And then finally at the end, I return all of my stacks. Simple, but it requires us to have an is container row, which also can be implemented in a number of ways. I use the fact that a row that has containers in it will actually have a square bracket. So all I do is I check, does my row contain a square bracket? If it does, then it's going to return true. And if it doesn't, it's going to return false. Okay, we're making some progress. The next thing we need to do is define how we're going to represent an instruction. So if we look at our inputs here, all of our instructions say move, int, from, int, to int. So our instruction, the important bits are these 3 integers. So we're going to define a data type that will store 3 integers so we can access them. I'm going to call mine count, from, and to. And I'm in C#, so it's relatively easy to do this. I've defined a record type that is just instruction, int count, int from, and int to. In your language, you might have to use a class, or you could use a JSON object, whatever your language supports. And just like we did with our supply stacks, once you have a data representation, once you know how it's going to look, what the data is going to look like, you're going to want to parse that in. And I'm going to recommend doing the same thing where you write a single parse instruction that takes in 1 row and turns it into an instruction you can use. I've written a little test here so that way once I've implemented it, I'm going to have some confidence that it's going to work. If it works for this example set, then hopefully it will work for a larger set. I've taken each of the instructions from the example, I've created a little test with them, and now I'm ready to implement this. Hopefully you were able to successfully parse a single row from the input into an instruction, and your test, when you run it, is outputting the correct values. For example, move 1 from 2 to 1 gives us an instruction with count 1, from 2, and to 1. Same for each of the other inputs. If you're not yet satisfied with what you have, go ahead and pause. I'm about to show my solution. And here it is. It's relatively simple. I've taken advantage of the fact that I know that every instruction row is going to contain 6 tokens. Move would be token 1, the first int is token 2, etc. And I use a split. So I take my string and I split it into those tokens, and then I ignore the move, from, and to, and just pull out each of the elements. So I pull out the count that's at index 1, I pull out the from that's index 3, I pull out the to from index 5, and then I parse it into integers, and finally I construct my instruction record and return it. So now that we have a way to parse a single instruction, we're going to do the same thing we did with our stacks. We are going to go ahead and write a parse instructions with an S that's going to go through our entire input, pull out our instructions, and then give us back a list or an array of all of those instructions together. I have defined 2 methods here. I have parse instruction, and I'm going to have a little helper for myself called is instruction row. If you think you can do it without the is instruction row, go for it. I'm going to use it. I think it makes it a little bit simpler for myself. And then I'm going to go ahead and put a little test in here where I parse in my sample.txt, parse in the instructions using that, and then I'm going to display the instructions. When I run this right now, it's not implemented yet. It's just going to show empty. There are no instructions yet, but once it's implemented, it should show that I have 4 instructions, and the instructions should match from the example. If all went well, you now have a test that's displaying all of the instructions correctly parsed in. For example, I have move 1 from 2 to 1 as the first input, and I get count 1 from 2 to 1. The second input also matches 3, 1, 3, 2, 2, 1. We got 2, 2, 1, and then finally 1, 1, 2. 1, 1, 2. So if you are not yet correctly parsing in and converting your instructions into instruction data objects, go ahead and pause. I'm about to show my solution. Here it is. Pretty straightforward. I give all of my rows to my parse instruction, and I just iterate through all of them using a for each loop. Check to see if it's an instruction row, and if it is, I add it to the list that I finally return. I parse it as an instruction, add it in, and get it back. And of course, the way I check to do this is I wrote a little helper called isInstructionRow, and I know that the only rows that are instructions will have the word move in it. So I say if my row contains the word move, go ahead and parse it as an instruction. We're super close. All we have to do is actually perform the instructions to the moves. To help with this, I'm going to recommend writing a method here that will do a single move rather than trying to do an entire instruction all at once. Let's see if we can get it to do a single move first. So I've written a method stub here for move, which takes a from integer, a to integer, and then our supply stacks. And the idea here is we should be able to observe a single move, make sure we got it working. It's a little trickier than you might think. So go ahead and build a test for this. I've built this test up here. I'm parsing in my supply stacks from the original input from my sample input here. And when I run it, I'm gonna be testing if I can perform these moves both forward and backwards. So you'll notice here, I go from move 2 to 1. So I'm gonna move from stack 2 to stack 1, and then move it back, stack 1 to stack 2. And then I'm gonna move from stack 1 to stack 3, and then from stack 3 back to 1. So that's my test. When I run it right now, I essentially get no changes because I haven't implemented move, so I get the same stacks each time. But after I've implemented it and I run this, ideally it's gonna give me some confidence that it's going to work for a bigger input. Hopefully you now have a working move method that allows you to make a single move from stack to stack. So for example, my test is showing this working. This is my original stacks. So I have D that I'm gonna move from 2 to 1. It should move D onto stack 1. And if I look at the output, sure enough, D is in stack 1, it's not in stack 2. Then I'm gonna move it back. So I take that D and I put it back on stack 2 here. So D is taken off, it's put on top of stack 2. Then I'm gonna test one more time, 1 to 3. So this is taking that N and moving it to stack 3. So now I have no N in stack 1 and it's in stack 3. And then I move it back from stack 3 to stack 1. So I'm confident that this move is gonna work if I have more rows, more stacks, more columns that I have to use. Go ahead and pause if you need to fix yours, but here is my solution. Relatively straightforward. I'm using lists, and so I'm gonna be popping and pushing using the list's appropriate interface. In this case, I get the stack from integer. One thing to note here is that my inputs, my instructions are coming with 1 as the first column, the first stack to select from. This happens to be index 0 in my data representation. So I have to subtract 1 from. Same with 2, I subtract 1 from 2 to get the correct index. I pull out the container that I'm gonna move. I go ahead and remove it from the from stack, and then I insert it at position 0, which is the top. That's how I'm representing the top of the other stack, and I put it in there, and that is how we get a single move operation. Next, we want to be able to perform an entire instruction. An entire instruction can have multiple things being moved from one stack to another. So we're going to write a method here, perform instruction, which takes in the instruction and the stacks and calls move the appropriate number of times given that instruction. I've written a little test here using our inputs and original stack here. And of course, when I run it, nothing happens because I haven't implemented it yet. So all of my stack states are the exact same. But ideally, when I am finished here, I can look at the example outputs and validate my test against it. And here we are, we now have a working perform instruction method. We run our test, we validate that the outputs match the example to give us confidence that it's gonna work on a bigger input. Here we are, we have DNZCMP, and then we get CM, ZNDP, MC, ZNDP, and then CM, ZNDP. Just like that, we're matching the example input and we have confidence it's gonna work. If yours doesn't match the example input, go ahead and pause. I'm about to show my solution. Here's my solution, relatively straightforward. Perform instruction, takes in this instruction, we get the count, and we just loop that many times calling our move method on the stack. Very straightforward. And finally, we have everything in place we need to actually finish and solve this puzzle. We just need to parse in our input, get our stacks, get our instructions, then iterate over the instructions, applying them to our stacks, and then finally printing out the result. Give it a shot. Hopefully it all went well and you have an output here that says that stack 1's top is C, stack 2's top is M, and stack 3's top is Z. That is what my output is. I'm about to show the solution, so go ahead and pause if you need to finish. And here is my solution. I clear so I don't have all of the test output above. I let it say that here's our final stacks. I'm gonna go ahead and read in my sample.txt one more time. I'm going to parse in my supply stacks, parse my instructions, and then I just iterate. I have this simple for each loop that goes over all of my instructions, calls perform instruction, that instruction on the supply stacks, and at the very, very end, I print my supply stacks. Once you have that working, go ahead and scroll on down to the bottom, get your puzzle input, go ahead, feed it into your program, swap out sample.txt for that puzzle input, cross your fingers, and if all goes well, you'll get your solution. Hopefully at this point you've submitted your solution and received a beautiful gold star. I hope you found this video helpful. If you did, let me know. Click that like button. If you want to see more Advent of Code guides, click subscribe so you'll be notified when they're uploaded. And as always, have a beautiful day. Keep on coding, keep on growing, and you're welcome back anytime.